Hello students. Today we see some more problems based on volume strength of hydrogen peroxide. Okay. So only in yesterday class we discussed about the volume strength of hydrogen peroxide and the relation between the normality, molarity, normal strength in grams per liter, and volume strength. Okay. Now we see the related problem. So 10 milliliter of hydrogen peroxide 10 milliliter of hydrogen peroxide liberate 12.7 grams of iodine from an acidic potassium iodide solution. So here important thing is so the hydrogen peroxide reacted with the potassium iodide. Hydrogen peroxide reacted with the potassium iodide in acidic medium, giving iodine. How much? 12.7 grams of iodine. So ఇక్కడ how much potassium iodide to react and no information. Here information is given about the hydrogen peroxide and also product. Just potassium iodide to react అయితే ఎంత iodine form అయిందో ఇచ్చింది మనకి. So with the help of these details we have to calculate the normality, molarity, volume strength, normal strength of the grams per liter, and percentage strength of hydrogen peroxide. So we know that one normality equal to how much? We know the relation 5.6 volumes of hydrogen peroxide. ముందు మనం నార్మాలిటీ ఫైండ్ అవుట్ చేయాలి. నార్మాలిటీ బేస్ చేసుకొని రిమైనింగ్ అని ఫైండ్ అవుట్ చేయొచ్చు. బికాస్ we know the what are the relation between normality, molarity, volume strength and volumes. See how to find the normality. So the equation, the reaction is given. So reaction between hydrogen peroxide and potassium iodide. So to perfect the reactant, what is we can write milli equivalents of hydrogen peroxide is exactly equal to we can write milli equivalents of potassium iodide. So the product is formed iodine. So we can write milli equivalents of iodine. So which information given? Given information is only about hydrogen peroxide and iodine. So have to equalize that only. So milli equivalents of hydrogen peroxide is exactly equal to milli equivalents of iodine. So milli equivalents mean normality into volume. Same normality into value. We can take N1 equal N2 V2. So I have to find the normality of hydrogen peroxide. How much volume is reacted? It is just 10 milliliter is reacted. So what is the normality of iodine? So there is not given normality. So the weight is given. So with the help of weight we are able to find it. Okay. What is the normality formula? Weight by gram equivalent weight into 1000 by V. This is normality. Only V is there. So we can write what is normality into 10. So what is the weight? The weight is given how much? I think 12.7 grams of iodine. Next, gram equivalent weight. So gram equivalent weight, what is the formula? It's molecular weight by n factor. So for iodine, so equivalent weight of iodine. So formula weight. Actually the one iodine it is 127. Here 127, there is a 254. Okay, two iodines are there. So I2 is there. Okay. So what is N factor? N factor means we know that so I2 is formed by iodide. Potassium iodide nunchi I2 form in manaki. Potassium iodide lo iodine into the I minus. So I minus become I2. So balancing 2I. So getting 2 electrons. And N factor for iodine is 2. That is again 127. So it's important one. Into 1000, so we get cancel. So therefore, what is the normality? It also will cancel. So here, how much will get? See, this point, this will get. So total normality becomes 10. Means normality of hydrogen peroxide is 10. So now we calculate the remaining one by one. Okay. If normality is 10, so take it as the first answer. Okay. So then what about molarity? So we know that molarity normal relation, normality equals molarity into n factor. So molarity is equal to normality by n factor. N factor. We are calculating for hydrogen peroxide. So hydrogen peroxide would have what is the n factor? 2, because it can release 2 H plus ions. So molarity is 5. Next, we find out volume strength. So we know that 1 normality is equal to 5.6 volume strength hydrogen peroxide. We can write volumes or otherwise volume strength of hydrogen peroxide. Volume strength hydrogen peroxide. Then what about 10N? So 10N equals how many volumes? How much volume strength? Simple, that is 56 volume strength, or we can write 56 volumes of hydrogen peroxide. So just calculating the first option, that is normality, is important. Then automatically with the help of relation we are able to do the remaining calculation. So normality completed, molarity completed, so volume strength completed. Next, just strength. Okay, so just strength, we know that so there is a one normality of hydrogen peroxide equals how many grams? One equivalent weight, like 17 grams per liter. So then what about 10 normality of hydrogen peroxide is equal to how many grams? So very simple, 170 grams per liter. So this is called strength. So grams per liter discuss cheste, this is called strength. Okay, it is a common method. So volume strength, it is only for hydrogen peroxide, that is in terms of available oxygen base exponentially. So next one more, the percentage is there. So percentage, already we know the relation. So 1 normality of hydrogen peroxide equal to how much? 1.7 percentage. So then what about 10 normality of hydrogen peroxide is how much? It is 17% of hydrogen peroxide. So this is the best problem to know the volume strength of hydrogen peroxide in all different measurements, okay, in all different expressions. Okay, see the next one. So a solution of potassium dichromate containing 4.9 grams per liter is used to titrate H2O2 solution. Here titrate means nothing but for the adding. Okay, so adding the procedure మనం డ్రాప్ వైజ్ యాడ్ చేస్తే దట్ ఈస్ కాల్డ్ టైట్రేషన్ అంటాం. సో టోటల్గా ఫైనల్ కన్క్లూజన్ ఏంటంటే దే ఆర్ రియాక్టెడ్. కాకపోతే సో వన్ కాంపౌండ్ బ్యూరేట్లో తీసుకుంటాం, వన్ కాంపౌండ్ కోనికల్ ఫ్లాస్క్లో తీసుకొని డ్రాప్ వైజ్గా యాడ్ చేస్తే దట్ అడిషన్ ప్రొసీజర్ is called titration. Simply titration అంటే no need to confuse. The titration means they are reacted. So reacted with the H2O2 solution containing 3.4 grams per liter in acidic medium. So it is given acidic medium. So I have to calculate what value of K2Cr2O7 will be required. React with 20 milliliter of hydrogen peroxide. Very simple problem. Okay. So normally I startingly is the problems model. That is given hydrogen peroxide is only the new thing. Half problem in the, so that is the reach is the problem. It's an old problem. It's a normality. Two compounds reaction అవుతే వాటి మిల్లీ ఈక్వల్ చేస్తాం. సో ఫస్ట్ దాని కానీ సెకండ్ దాని కానీ వాల్యూమ్ ఫైండ్ అవుట్ చేస్తాం. ఇట్స్ వెరీ సింపుల్ ప్రాబ్లమ్. బట్ దీంట్లో ఎక్స్ట్రా థింగ్ ఏంటంటే ఐ ఆల్సో క్యాలిక్యులేట్ ద స్ట్రెంగ్త్ ఆఫ్ హైడ్రోజన్ పెరాక్సైడ్ ఇన్ టర్మ్స్ ఆఫ్ అవైలబుల్ ఆక్సిజన్. ఓకే, సో స్ట్రెంగ్త్ ఆఫ్ హైడ్రోజన్ పెరాక్సైడ్ ఒకటి మనం ఎక్స్ట్రాగా ఫైండ్ అవుట్ చేయాలి. ఓకే, so in terms of available oxygen, so normal strength ante grams per liter, we know that it is given. So it is given a strength in terms of available oxygen. Strength in terms of available oxygen ante that is volume strength. Okay, first we read this step. So these two are reacted. Potassium dichromate, hydrogen peroxide are reacted. So we can write the milli equivalents of K2Cr2O7 or dichromate ion we can write is exactly equal to milli equivalents of hydrogen peroxide. So normality into volume is equal to its normality into volume. So మనం find out చేయాల్సింది calculate what it is. So what value of K2Cr2O, ఈ value find out చేయాలి. So we must know normality. So what is the formula for normality? The value find out చేయాలి. So it is given a 1 liter ichindi. The information is given to calculate the normality 4.9 grams per liter. So per liter slow, what is the formula of normality? Weight by gram equivalent weight into 1 by volume in liters into V. So ఇక్కడ మనం cancel చేయడానికి there is no choice because separate it is given 4.9 grams per liter. Again we have to calculate the volume required for this reaction. Okay, so ఇక్కడ ఇచ్చిన only clue to calculate the normality. ఇక్కడ కూడా hydrogen peroxide కూడా there is no normality is given. It is also given in terms of strength అంటే weight by volume ఇచ్చింది. అంటే we can write 3.4 gram weight. Okay, we do one more step. First write the formula. Weight by gram equivalent weight into 1 by V liters. Why you are taking liters means here information is given in terms of liters covered. So the volume, so how much it is given, its separate volume is not there. Well, yes, 20 milliliter of hydrogen peroxide is given. So what is the weight? The weight of potassium dichromate is given how much? So 4.9 grams by, what is the gram equivalent weight means molecular weight by n factor. So what is the separate we calculate it. So equivalent weight or gram equivalent weight, both are equal. So K2Cr2O7, it's what is the molecular weight. So molecular weight by n factor. So n factor how to calculate? We know that Cr2O7 minus 2 becomes 2Cr plus 3. So it actually it's chromium oxidation number plus 6. So here by taking 6 electrons it takes place. So n factor 6. So what is the molecular weight? Potassium 1 potassium 39. Chromium 2 chromium 52. Each oxygen carries 16 means 112. So total we get how much? 18, 4, 18. So 294. So here we'll get Okay, for equivalent weight of potassium dichromate is 49 into 1 by 1 liter, so no need to write 1 by 1. So what is the weight? The weight of hydrogen peroxide is given how much? It is given 3.4 grams per liter. 3.4 grams. So equivalent weight means molecular weight by its N factor. In fact, hydrogen peroxide can release 2 H plus ions. Okay. సో నార్మల్ ప్రాబ్లమ్స్ మనం వాల్యూమ్ కట్ చేస్తాం. సో ఇక్కడ ఏంటంటే జస్ట్ ఇన్ఫర్మేషన్ నార్మాలిటీ కోసం ఇన్ఫర్మేషన్ ఇచ్చిండు. సో రియాక్షన్కి సపరేట్గా 20 ml సపరేట్గా ఇచ్చిండు హైడ్రోజన్ పెరాక్సైడ్కి. కాబట్టి ఈ రెండు 1 లీటర్ 1 లీటర్ చేయలేదు. ఓకే, so I have to write this also. So here I will get okay, point 1. So 1 into value equals to 74. Sorry, so 17. So it can be written as 34 into 2. So value equal to total 40 milliliter. Okay. So what is the volume of potassium dichromate? 40 milliliter of potassium dichromate is required to react with 20 milliliter of hydrogen peroxide. So next, in the same problem, so the second case is there. So calculate the volume strength ichchundu. So calculate the volume strength. Danni manam ఇచ్చింది ఏంటంటే strength in terms of available oxygen అన్నాడు. Strength in terms of available oxygen means volume strength. So here one normality, we know that one normality of hydrogen peroxide is equal to 5.6 volumes. Volumes and volume strength are not okay. So volumes of hydrogen peroxide. Then what about here what is the normality of this one? So normality already మనం ఇక్కడ calculate చేస్తాం. So 3.4 by 34 by 2. So we get 17. So 34 by 10. So we get this part is equal to 0.2. No need to do the again. So 0. Normality of hydrogen peroxide is equal to how many values? So 0.2 into 5.6. So it gives 1.12 values. Okay. C is one more important one. So actually the problems based on hydrogen peroxide are generally really very big in 4 or 5 sentences. Okay, but just understand the problem, just make it very short. Okay, so the answer will be very easy, just don't see the size of the problem. Okay, so when 100 milliliter of an aqueous solution, so 100 milliliter hydrogen peroxide is titrated. So titrated means reacted with excess potassium iodide, some potassium iodide in dilute H2SO4. Means in acidic medium, hydrogen peroxide is reacted with potassium iodide, and we know that it releases iodine. So here, so ఇక్కడ దాకా మనకి ఇప్పటిదాకా రీడ్ చేసింది ఏంటంటే లాస్ట్ ప్రాబ్లం. సేమ్ మిల్లీ ఈక్వలెన్స్ ఆఫ్ హైడ్రోజన్ పెరాక్సైడ్ దేంతో చేసినాం, మిల్లీ ఈక్వలెన్స్ ఆఫ్ పొటాషియం అయోడైడ్. సో దానికి పొటాషియం అయోడైడ్ అగైన్ లిబరేట్స్ అయోడిన్, కాబట్టి మిల్లీ ఈక్వలెన్స్ ఆఫ్ I2 అయింది. సో దీంతో I2తో స్టాప్ చేయకుండా ఇంకో స్టెప్ ఇచ్చాడు. అది ఏంటంటే దట్ I2 ఈజ్ రిక్వైర్డ్ 50 milliliter of 0.1 m Na2S2O3 solution for complete reaction. అంటే ఇక్కడ ఫామ్ అయిన I2 ఎంత వచ్చిందంటే ఇంతకుముందు ప్రాబ్లంలో డైరెక్ట్ ఎంతో I2 ఫామ్ అయిందో ఇచ్చిండు మనకి. కానీ ఇక్కడ I2 కూడా ఇవ్వకుండా హౌ మచ్ I2 ఈజ్ ఫార్మ్డ్ అంటే దట్ I2 is equal to nothing but that I2 is required for the complete reaction with 50 ml 0.1 m sodium thiosulfate for complete reaction. So calculate the strength and volume strength of hydrogen peroxide. So we know that strength and volume strength and మనం ఫైండ్ అవుట్ చేయాల్సింది నార్మాలిటీ. సో నార్మాలిటీ ఆఫ్ హైడ్రోజన్ పెరాక్సైడ్ చేస్తే దాన్ని బేస్ చేసుకొని వాల్యూమ్ స్ట్రెంగ్త్ నెక్స్ట్ నార్మల్ స్ట్రెంగ్త్ ఫైండ్ అవుట్ చేయొచ్చు. ఓకే, see first so milli equivalents of hydrogen peroxide are exactly equal to దీంతో రియాక్షన్ అయింది కాబట్టి we can write milli equivalents of potassium iodide. So this potassium iodide to react it releases so it is reacted with this. So both reactants కాబట్టి దీని ఇన్ఫర్మేషన్ ఇస్తే రెండు ఈక్వల్ చేస్తే మనకు ప్రాబ్లం అయిపోయేది. But it is also not given. It liberated I2. So it liberated I2 కాబట్టి we can say milli equivalents of I2. So I2 information is taken to stop చేస్తాడు, but I2 information is also not given. So I2 also used to react with Na2S2O3. So మనం ఫైనల్ గా రాయాల్సింది milli equivalents of milli equivalents of Na2S2O3 or S2O3 minus 2. So మనకి given details. So details are given about hydrogen peroxide ఇచ్చిండు, next sodium thiosulfate ఇచ్చిండు. So for calculation we use this relation milli equivalents of hydrogen peroxide exactly equal to milli equivalents of sodium thiosulfate. Simple, normality into value equal to normality into volume. So what is the normality of, we have to find the normality of hydrogen peroxide. So what is the volume of it is given for hydrogen peroxide, value directly given to 100 milliliters. So what is the normality of Na2S2O3? So normality, so it is given molarity is given 0.1 into n factor. So we know that normality equals molarity into n factor. So S2O3 minus 2 ఇక్కడ రియాక్ట్ అయ్యే పార్ట్ ఏంటి, we know that sodium కి Na plus always react అయ్యే పార్ట్ S2O3 minus 2 thiosulfate in acidic medium separately given H2SO4 acidic medium అని ఇచ్చిండు. So you remember that S2O3 minus 2 changed to tetrathiocyanate, sorry not cyanate, thionate. Okay, tetrathiionate. So S2O3 ఇక్కడ వచ్చాయి అనేది Na2 plus పోతే S2O3 minus 2 thiosulfate changed to tetrathiocyanate. Okay, tetrathiocyanate or tetrathionate లో చేంజ్ అవుతుంది. So I will write that relation. So S2O3 minus 2 it changed to S2O4 minus 2. Sorry, tetra. Okay. S4O6 minus 2. So now here 4 sulfurs are there. Actually మనం 1 S2O3 reactants కి మనం మార్చొద్దు యాక్చువల్గా 1 mole కి క్యాలిక్యులేట్ చేయాలి ఈక్వలెన్స్ అన్నప్పుడు. బట్ సో ఫర్ నెంబర్ ఆఫ్ ఎలక్ట్రాన్ ఫైండ్ అవుట్ చేయడానికి కోసం బ్యాలెన్స్ ఛార్జింగ్ కోసం ఆటమ్స్ బ్యాలెన్స్ చేస్తాం ఇక్కడ 2S2O3 minus 2 S4O6 minus 2. సో వాట్ ఈస్ ద సల్ఫర్ ఆక్సిడేషన్ నెంబర్ అని చూస్తే మనకి the sulfur oxidation number change is only 2 electrons. Okay, 2, check the sulfur, 2x minus 6 equal minus 2. So like this plus 2 for one sulfur, second sulfur also plus 2, third sulfur also plus 2, fourth sulfur also plus 2, 4 sulfurs are there. Each sulfur is having plus 2 oxidation state. So So here 4x minus 6 equal to minus 2. So here it is minus 2. Okay, 4x. So S2 3 minus 2. Okay, 4x. So we must get each oxygen minus 2. So it's minus 2 will equal to minus 2. X equal to 2.5. Means one sulfur changed to 2 plus 2 to plus 2.5. So one sulfur plus 2 నుంచి plus 2.5 అయింది. అట్లా ఎన్ని సల్ఫర్స్? 4 sulfurs. 4 sulfurs అంటే so how much we will get? So 2 and becomes 2.5, 2.5, 2.5. So 4 sulfurs 2 నుంచి 2.5 పోయిందంటే there is a change in the number of electrons, 4 electrons. Okay, so the charge increase means it is oxidizer. So oxidizer means it is losing electrons. Means here it is total 2 electrons. Okay, so 0.5, 0.5, 0.5, 0.5, total 2 electrons. Here one more important. So 2 electrons carbon direct N factor 2 random. So we know that that's right. So for N factor we have to calculate for 1 mole reactant. 1 mole reactant తీసుకోవాలి. ఇక్కడ products balance చేయడానికి ఎంత నెంబర్ చేంజ్ చేసినా దాన్ని కన్సిడర్ చేయం. సో కానీ ఇక్కడ మాత్రం 1 మోలే ఉండాలి. బట్ ఫర్ బ్యాలెన్స్ చేసి మనకి 2 మోల్స్కి వచ్చింది క్యాలిక్యులేషన్. ఫర్ 1 మోల్ క్యాలిక్యులేట్ చేస్తే ఇట్ ఈస్ ఓన్లీ 1 electron. సో N factor for S2O3 minus 2 is 1 only. So what is the value? 50 milliliter is given. Okay. There is a 0.1. Okay, normality we will get so 0.2. Sorry, 0.02. 1 by 20. 0.05 normality. So actually in the question, directly it is not asked about the normality. So the question was find the volume strength. So volume strength find out చేయాలంటే with the help of given details మనకి normality find out చేయడానికి సరిపోతాయి. So ఆ normality తోని we calculate volume strength. We know that 1 normality of hydrogen peroxide is equal to 5.6 volume strength hydrogen peroxide. So then what about 0.05 normality hydrogen peroxide is equal to how much? This we have to remember 1 normality 5.6 value. Yesterday we determined that. Okay, so on this we will get how much? 1 normality 0.28. On calculation we will get 0.28. Volume strength ne manam volumes అని రాస్తాం. Okay, volumes of hydrogen peroxide. In the same problem, the second case was to calculate the percentage strength. So already in the formulas we know that the formulas of hydrogen peroxide, we know that 1 normality of hydrogen peroxide is equal to 1.7%. So then what about 0.05 normality hydrogen peroxide is how much? So on overall calculation, okay, so there's some more problems are there. So tomorrow we complete this topic. Okay, but try to practice 2 to 3 times at least. Okay, that's the minimum value. Okay.